Hello, this is the beginning of our SHS2 Core Mathematics program, brought to you by the Center for National Distance Learning and Open Schooling, CENDLS. I am Betty Osei. Our first topic is modular arithmetic. This may not sound familiar, but by the end of the lesson, you should be able to calculate the value of a number in a given modulo. In our earlier work, we learned about the number systems and how to operate on them. We learned to add, subtract, multiply, and divide numbers. And we know the basic rules that control these operations. We also know that when we add or multiply two integers, the result is always an integer. This is also true when we subtract one integer from another. But it is not true for division of one integer by another. In this topic, modular arithmetic, we shall deal with integers and these operations again, but in a different way. Modular arithmetic is a system of arithmetic for integers, where numbers wrap around upon reaching a certain fixed value called the modulus, or modulo, and sometimes shortened as mod. But first, we want to look at what a linear variable and a cyclic variable is. Now, we have learnt about the number line in our SHS1 syllabus. On the number line, we have the positive numbers on the right, the negative numbers on the left, and 0. We also learnt that as we move to the right, the numbers increase in value. And as we move to the left, they decrease in value. Now, here's an example of a number line. Today, we want to take a portion of this number line, a positive side of the number line, starting from 0 to 12, with a variable number x moving along the line. Now, this variable is called a linear variable, and it can represent any distance from 0. Now, suppose this number line is bent so that the point marked 0 and the point marked 12 coincide to form a circle, as you can see. Then we can drop the 12 and maintain the 0, which represents the same point. Then our variable x will now begin to move along the circumference of the circle in either direction, and then it passes over these points repeatedly. Now, this variable is now known as a cyclic variable. As I said earlier, modular arithmetic is a system of arithmetic for integers, where the numbers wrap around upon reaching a certain fixed value. Now, this fixed value is what we call the modulus, or modulo, or mod for short. And the plural is moduli. Now, with this background, we want to take a look at a few examples. You can see a 12-hour clock face. There are only 12 points on it. And these points are numbered from 0 to 11. The hands of the clock pass over these points repeatedly. Now, because 0 and 12 have the same position, we say the clock face works with mode 12. Again, we are looking at a 9-hour clock face. There are only 9 points on it, numbered from 0 to 8. The hands of the clock will pass over these points repeatedly. And because the 0 and the 9 have the same position, we say the clock face works with mode 9. Now, in a 12-hour clock, suppose the time is 9 o'clock. We want to see the time after 5 hours. Remember, our time is 9 o'clock. And so after 1 hour, it goes to 10 o'clock. After 2 hours, it goes to 11 o'clock. After 3 hours, the hand will be at 12 o'clock. And we keep moving. And so you will find that in 5 hours, the time will be 2 o'clock. And I'm sure you can see that on the face of the clock. Again, we want to see the time after 13 hours. Remember, the time is now at 9 o'clock. And so we move hour after hour. And you will find that the time will be 10 o'clock after 13 hours. Again, we want to look at the time after 16 hours. Remember, we are starting at 9 o'clock. So we move hour after hour until after 16 hours, we find that the hand will be at 1 o'clock. Now we shall use both the clock and calculations to show you how modular arithmetic works. We shall look at the 12-hour clock face again. Now, if the hour hand starts at the 12 o'clock position and moves 15 hours, it ends at 3 o'clock. We can also use calculation to show this. What we do is we divide 15 by 12, which is the mode. That gives us 1 remainder 3, where 1 is the quotient and 3 is the remainder. And 12 is said to be the divisor or the modulo. And so we say 15 is equivalent to or equal to 3 in mode 12. This means that 15 minus 3 is a multiple of 12. Now, our interest in modular arithmetic is the remainder and not the quotient. The modulus we are working in becomes the divisor. For example, to find a number in mode 4, we divide the number by 4. Write down the remainder as the answer. So for instance, if we want to write 13 in mode 4, we will divide 13 by 4. And that gives us 3 remainder 1. And therefore we say 13 is equal to 1 in mode 4. Again, we want to write 19 as a number in mode 4. What do? We divide 19 by 4, and that gives us 4 remainder 3. And therefore, 19 will be equal to 3 in mode 4. The remainders are usually the important things in modular arithmetic. As you can see, it is very important for you to know your multiplication tables very well, because you need to divide and keep the remainders as the answers to these questions. Now, when working in the following moduli, these are the possible remainders you can have. For mode 3, the remainders are 0, 1, and 2. In mode 4, the remainders we have are 0, 1, 2, and 3. Now, I'm sure you can see how we are getting these numbers as the remainders. That is because if you divide by 4, you cannot get a remainder of 4. And so the remainders will only stop at 3. If you are dividing by 6, you can't have a remainder of 6. And so your remainders start from 0 to 5. And that is how it goes. And so for mode 12, our remainders are 0, 1, 2, 3, up to 11. Now, suppose we want to write 12 as a number in mode 5. Do you remember what we did? We divide the 12 by the mode, which is 5, and we keep the remainder as our answer. In this case, we get a remainder of 2. So we say 12 is equal to or equivalent to 2 in mode 5. Again, we want to write 27 as a number in mode 5. So we divide 27 by 5, and we get a whole number of 5 and a remainder of 2. So we say 27 is equivalent to or equal to 2 in mode 5. Now, with the same idea, we want to try some questions. So let's simplify the following in the given modulo. Example A. 13 in mode 5. Like we said before, we will divide 13 by 5. That gives us 2 remainder 3. And so we say 13 is equal to 3 in mode 5. Another way of saying this is that 13 is equal to 2 times 5 plus 3. And therefore, 13 is equal to 3 in mode 5. B. 29 in mode 7. We want to write 29 as a number in mode 7. So we would divide the 29 by 7, and that gives us 4 remainder 1. And so we say 29 is equal to 1 in mode 7. An alternative way of working this is to write 29 as 4 times 7 plus 1. You know 4 times 7 is 28. 28 plus 1 is 29. And therefore, the remainder is 1. So we say 29 is equal to 1 in mode 7. Again, we want to write 31 in mode 9. So what do? We divide 31 by 9, and we get 3 remainder 4. So 31 is equal to 4 in mode 9. The alternative method is to write 31 as 3 times 9 plus 4. And therefore 31 is equal to 4 mode 9. We want to write 28 as a number in mode 5. So once again, we divide 28 by 5. That gives us 5 remainder 3. And so we say 28 is equal to 3 in mode 5. You can use the alternative method. Write 28 as 5 times 5 plus 3. Therefore, 28 is equal to 3 mode 5. So in mode 5, 13 is equivalent to 28. And that is because both of them have the same remainder, which is 3, when divided by 5. So if any two whole numbers, let's say m and n, have the same remainder when they are divided by a number x, then the two numbers are said to be equivalent in that mode. And so we'll say m is equivalent to n in mode x. Good. Can you think of any real-life situations where modular arithmetic is used? Well, I can think of a few. And when I mention them, I'm sure you can also think of some. The first one is the sequence of market days. You know that in a village, market days are held every 4 days or every 5 days. So suppose this week a market day falls on Monday, you should be able to write down the other market days. Now we want to look at one such example. Suppose in a village, the market days come every 4 days. And this week, the market day falls on a Monday. Can you write down the sequence of market days for the next few weeks? Now, by counting forward from Monday, we observe that the next market day falls on a Friday. That is 4 days after that. After Friday, the next market day will fall on a Tuesday. And then after Tuesday, the next one will fall on a Saturday, followed by Wednesday, and then Sunday, and Thursday, and finally it will come back to Monday. And so the sequence of market days will be Monday, Friday, Tuesday, Saturday, Wednesday, Sunday, and Thursday, and back to Monday. Now, this is an example of a question that you can solve by using modular arithmetic. You can draw a clock face, put the days on it, and move every 4 days to get your answers. Again, another example is when duty schedules for prefects and workers are planned. And so we have 3 students, Ben, Lucy, and Betty, who take it in turns to do library duties. And they work on Mondays to Fridays. But the library is closed at the weekends. Ben was on duty on the first Monday of the term. After how many weeks do you think he'll be on duty again on a Monday? We can show the days on which Ben goes on duty by moving on the circumference of the circle. Now you can put numbers on the points on the circle, or you can put the days of the week. When we do that, you will find that if the first day that Ben goes on duty is a 0, then the next one will be a 3. Then the next time he goes will be a 1. Then the next time will be a 4. The next time will be a 2 before he comes back to 0. So then we'll be working with mode 5. This means that we'll go 3 times clockwise round the circle before returning exactly to 0. So Ben is on duty on a Monday in 3 weeks' time. Good. Now, we have learned a few things in this lesson. The first one is modular arithmetic is a system of arithmetic that deals with integers. Again, we said to change a number to a given modulo, we divide the number by the modulo and we take the remainder for our answer. Remember, our interest in modular arithmetic calculations is the remainder and not the quotient. The modulus concerned is the one we use to divide, or the divisor. Now we have come to the end of the lesson. I hope you have enjoyed it, and I hope you find it very easy. Please take your time, practice the concepts we have discussed carefully. Try some of the questions in the quizzes we have, and make a date and join us for another interesting lesson. Goodbye.